questions with you, right? Okay. If we have dy over dx equals x minus y. Slope fields, you see slope fields all the time if you ever watch the weather on TV. They put up like the way the wind is blowing, and that's a slope field, or where the fronts are moving, that's a slope field. They're used in meteorology all the time. They're used at other things too, but that's the main place you guys might see them. So the next time you walk through your house, or you think, I wonder what the weather's going to do, especially since there's a chance of snow, you might throw it up there and you will see a slope field.
Cool.
Now, okay, fine. When you get old and your kids need to know what to wear, you'll look it up and you'll be like, oh my gosh, I learned this in calculus.
I'll be like, hey kids, you should probably figure out what to wear before you're 30. I feel like they should understand.
Well, now, when they're 6, somebody has to tell them whether to put a coat on or not, Harrison. I hope you have a good wife.
I feel like I'll just walk outside and be like, it's a little chilly. We should put a coat on.
Okay, dy over dx, remember, is slope. That's derivative, which is slope, right? So this says the slope is equal to x minus y. Now, let's think a minute about slope. What is a zero slope? Horizontal. What is an undefined slope? Vertical. Now, if I have a slope of 1, isn't that kind of just a little bit slanted? And positive is up to the right, negative is up to the left. Is a slope of 2 steeper than a slope of 1?
Yes.
Now, when we do slope fields, these are approximations. You cannot do an exact slope field on what we have to do it on. Okay?
What you're saying, we can't miss it.
Well, yeah, you can, because it's a positive, not a negative, and things like that.
Well, the slope fields that
Okay.
I saw them do were insane.
Here is the equation that we're using.
Okay.
This point right here is 0, 0, correct?
Yep.
What is x?
0.
What is y?
0.
So I fill it in. What is my slope right here? 0. And I draw a horizontal line right there. Okay? What is this point? 1, 0. What is the slope? 1, which is? Because 1 minus 0 is 1. Okay? What is this point? 2, 0. What is the slope?
2.
So it's steeper than this, right? Okay? What is this point?
0, 1, 0, 1.
What is the slope? So it's going to look like this. Agreed? What is this? So it's going to be a little steeper, right? This point. What's the slope? Now let me tell you what's going to happen. If this is 0, this is 0, what is this going to be?
Zero.
This is 0,
Zero.
and this is 0.
Zero.
Harrison.
Yeah, you can stop. I would love.
Right?
Holy.
Are you with me?
Yeah.
So now,
Well, that means that it's the other side.
what is this one?
Opposite.
What is the slope right here?
1, 1.
2, 1. 1.
The point is 2, 1. What is the slope?
1.
So, do you see that this is 1, this was 1? Do you think this is 1?
Probably.
What about this one? Is this one 1? I'm not sure that one's 1.
Yeah.
That's negative.
You think? This point is 0, -1. I think that makes it 1, doesn't it?
Yeah.
What is this point? -1, -2. Is it also 1?
Yes.
See, I'm coming up with a pattern.
Yes.
What is this? This point is 1, -1. 2, this was 2.
Yep.
This was 2. Think this was 2?
Yes.
It's hard to tell much difference between 1 and 2, isn't it?
Yes.
1, 2, 1. Why isn't it missing?
On 2, 1. Because if x is 2 and y is 1, 2 minus 1 is 1. Right? Okay, here we are at this point, which is what? What's the slope? 3. That's going to be steeper.
Whoa.
What's this point?
4.
So it's steeper. What's this point?
3.
No, the slope is 3, isn't it?
Yeah.
What is this point? This is 1, 2, -1. Right? This was a -1. Do you think, what's this? No, is this? Yeah, -1. And this is -1, isn't it? What is this?
That's probably -2.
Yeah.
-2.
What is this?
-3.
Yeah.
What is this?
Negative 3.
And that's how we do slope field.
Well, it's like a magnet.
Does that make sense?
Yeah.
Then you just plug in x. You just plug in x. All right, can we go to problem, I'm debating if I want to do 17 or 18. Let's do 17. Okay, on the worksheet, problem 17, what is it? Thank you. All right, we could do a slope field, right? You can do that. I don't have to do that for you. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line to the curve through the point 1, 1. How do I have a point to find a tangent line? What am I missing? Slope. Do I have a formula for slope? So what is my slope? My point is 1, 1, 1/2. Agreed? So the equation of the line is y minus y equals 1/2 x minus x. So is y equal to 1/2 x plus 1/2? Now what does it ask me to do? Estimate the value of f of 1.2, which means when x is 1.2, what is y? Is y equal to 1/2 1.2 plus 1/2? What is y? 1.1. Are you with me? Now, find the particular solution, y equals f of x, to the differential equation with the initial condition of f of 1 equals 1. All right? Here's my differential equation. What did we do yesterday? We first put y with dy and x with dx, correct? So do I have dy over y equals x over 2 dx? Is that what I have? Yes? We're good with this. What's the antiderivative of dy over y?
1. 1.
Is this 1 over y dy?
Ln of y.
Ln of y. You all have to know that. When y is in the denominator, the antiderivative is ln of y. All right? Equals x squared over 4 plus c. Is that right? How do I find c? Of what? 1, 1. Yes? So is ln of 1 equal to 1/4 plus c? What is ln of 1? So 0 equals 1/4 plus c. What is c? Right? So is my equation ln of y equals 1/4 x minus 1/4? Is that true? Is that true? And what does it tell me? Use your solution to find f of 1.2.
Already found that one.
Well, we found an approximation of it. We didn't find it exact. What? It should be. So lose my x squared. Is that better?
Yeah.
Sorry. So, what do I know? What am I finding now? I'm finding y, aren't I? And x is 1.2. So, ln of y equals 1/4, 1.2 squared minus 1/4. Right? Well, that would be nice. However, can I get a value? Griffin, can you get me a value? No?
0.11 ln of y equals 0.11?
Exactly?
Yes.
So, ln of y equals what?
0.11.
How do I find y? Remember when we went from logarithms to exponents, exponents to logarithms. Isn't this base e?
Yeah.
So e to the 0.11 equals y.
Oh, that's cool. That's pretty much marked ln.
Okay. So what is y? I was very close on my estimate. Now, my question is, was my estimate from Part B that I found earlier an underestimate or an overestimate?
Technically under.
What do you mean typically under?
I said technically.
Technically, okay. I was like, what do you mean typically?
No.
Okay. Any idea why by looking at that graph? Because maybe it was a concave up at that point? Does this make sense?
Like at the very beginning, when we take the antiderivative, where does the dy go?
The antiderivative, when I take an antiderivative, the dy goes away. The dy designates a derivative. When it's not a derivative anymore, it's gone. The same place the dx went.
So then it wouldn't be like ln y times y?
No,